Okay, now we need to calculate the singular values. And that's just eigen. If you remember how we find the eigenvalues of the matrix, first we use the determinant function, and then we get the characteristic polynomial. Let me pull up the previous tutorials just to refresh your memory. Okay, so for step 3, there's a sequence of steps, but we're just going to, since we've already looked at them, we're going to skip right to the value. But let me refresh your memory. Here's how you calculate the eigen values of matrix. So let's say this is our matrix. We take the identity matrix, that's just one across diagonal, multiplied by lambda. This is just the thing that is meant to be determined. This is the indeterminate, and we want to determine what the values of lambda are. So we multiply the scalar value by this identity matrix, and we get lambda across diagonal. Then we take the difference of matrix A minus this new matrix. And it gives us this characteristic polynomial. And then we solve for lambda. We get 2 roots. We put x's for our eigenvector. And then we solve for the roots. And these will be the values for our eigenvector. Yeah, so this matrix is that matrix after we plug in one of these eigenvalues. So for this matrix, we chose 1. So we plug in 1 inside the we plug in 1 for lambda, and this matrix will be changed to that matrix. So we will get the eigenvector when we solve this system. Okay, so I'm going to skip this whole step and just give you the eigenvalues. These 2 matrices. A transpose times A times A transpose. The eigenvalues for these 2. I am going to return to collab. This is step number 1. This is step number 1. Step number 2 was this. Okay. Step number 3. The eigenvalues. So I'm going to denote this as ATA and this one AAT. Run that again. This. Now, if you want to calculate the eigenvalues, there is an attribute, or I should say object in NumPy called linear algebra. So I'm going to go np.linearalgebra and eigenvalues. So let's extract the eigenvalues for the first matrix. This will give us 50 and 200. If I do the same for the other one, yeah, so step 3 is eigenvalues for both matrices. I'm going to print this one, and I'm going to print this one. And so the eigenvalues are 50 and 200. But what we do is we take the square roots of these. So the square root of 200, is what? 200 times to the power 0.5. That's 14.4. Just like we have here. 14.4. And the square root of 50 would be 7.07. Okay, so we have found the matrix S The matrix contains the singular values. So the square root of these values are the singular values, which I will denote as sigma. So sigma sub 1 will be, let's just take the first one at 0. But then I need to take the square root. So I have to import the math library. So import math. And then I'm going to go math.sqrt. And the same thing for sigma 2. I'm going to print these. So sigma 1 will be 14.14, and this one will be 7.7. Okay. So we get this matrix. This is actually step 4, right? Step 3 is just sigma 1 and sigma 2. So sigma 1 we said was equal to 200. Sigma 2 was equal to 50. Then for number 4, we just take the square root of those sigmas. So let me just add another matrix.